Hello everyone, I'm Jia Xu. I'm here to explore a critical question. Could COVID-19 increase the risk of dementia in those who recover from it? COVID-19 is often regarded as a respiratory illness, but accumulating evidence suggests that its impact on the brain may be far-reaching, potentially leading to long-term cognitive effects. This presentation is built on current research findings and a critical analysis of the mechanism through which COVID-19 might affect cognitive health in the long run. Let's start with some background on this topic. COVID-19 primarily affects the respiratory system, but as more data becomes available, researchers are observing significant neurological and psychiatric effects in survivors. In a major study by Taikui et al. 2021, published in the Lancet Psychiatry, a cohort of 236,379 COVID-19 survivors was followed for 6 months post-diagnosis. Within that period, over 33% received a new neurological or psychiatric diagnosis. This number includes both mild and severe cases, with 12.84% being first-time diagnosis, meaning these patients had no prior record of such conditions. Notably, in patients who were admitted to the ICU, the rate of diagnosis jumped to 46.42%, with nearly 26% of these being first-time diagnosis. These findings raise concerns about the broader implications of COVID-19 on brain health. Conditions like ischemic stroke, dementia, and anxiety disorder were some of the most common diagnoses, showing that the virus may have far-reaching effects beyond acute illness. However, these findings are based on observational data, so while the association is strong, causation is still unconfirmed. While these statistics are striking, it's essential to critically examine the data. Let's look at some limitations and factors to consider. First, observational nature of the study. Most of the research connecting COVID-19 to cognitive and neurological issues is observational, which limits our ability to establish causation. Observational study can show correlation but cannot provide that COVID-19 directly causes these issues. Factors like age, socioeconomic status, and pre-existing health conditions may also play significant roles. For instance, many severe COVID-19 patients are older adults who are already at higher risk for dementia. Second, confounding variables. The studies include individuals with diverse health backgrounds. Pre-existing conditions like hypertension, diabetes, and cardiovascular disease are all known to increase the risk of both severe COVID-19 and dementia independently. Therefore, it's challenging to determine whether COVID-19 itself is an independent risk factor for cognitive decline or if it exacerbates existing vulnerabilities. Third, limited longitudinal data. Since COVID-19 is still a relatively recent phenomenon, most studies only follow patients with 6 months to a year. However, dementia and other neurodegenerative conditions can develop over years. Without long-term study, we cannot be certain if COVID-19 leads to a sustained increase in dementia risk, or if those cognitive issues will subside over time. Despite these limitations, the association between COVID-19 and neuropsychiatric conditions is significant enough to warrant serious investigation, especially given the potential long-term public health implications. To better understand why COVID-19 might affect cognitive health, researchers have proposed several mechanisms. Here are the primary ones. First, neuroinflammation and microglial activation. COVID-19 often induces a powerful inflammatory response, commonly known as cytokine storm. This cascade of pro-inflammatory cytokines can cross into the brain, trigger neuroinflammation. When microglial cells, the brain's immune cells, are activated chronically by inflammation, they may begin to damage the health neurons. This process of prolonged neuroinflammation has been associated with neurodegenerative disease, including Alzheimer's and Parkinson's. Hanka et al. 2020 have emphasized that sustained microglial activation could accelerate cognitive decline, making this a possible pathway for COVID-19 related cognitive impairments. Second, blood-brain barrier disruption and vascular injury. COVID-19 has been linked to endothelial cell dysfunction, which can weaken the blood-brain barrier (BBB). The BBB normally acts as protective shield, preventing harmful substance from entering the brain. When the BBB is compromised, it allows inflammatory molecules and even potential pathogens to infiltrate the brain, leading to further damage. Studies like Lee et al. 2021 highlight vascular injury as a critical factors, as it disrupts blood flow and can lead to the formation of small clots, both of which are risk factors for cognitive impairments and dementia. Third, direct viral invasion and hypoxia. Although still debated, some research suggests that SARS-CoV-2 may have ability to enter the brain directly. For instance, the virus could potentially reach the brain via the olfactory pathways, which is involved in smell. Once in the brain, the virus might infect neurons directly, leading to neural damage. Additionally, severe COVID-19 often result in hypoxia or lower oxygen levels due to respiratory issues. Hypoxia can cause widespread damage to the brain cells, particularly in regions responsible for memory and executive function. Mainhardt et al. 2021 discussed how this combination of direct invasion and hypoxia could contribute to the cognitive decline. Together, these mechanisms offer a possible explanation for the neurological symptoms observed in COVID-19 patients and emphasize the needs for further research. And next part is about the comparison to other respiratory infections. Research shows that COVID-19 patients have a higher risk of neuropsychiatric diagnosis compared to the patients with other respiratory infections, like influenza. For example, the hazard ratio (HR) for any neurological or psychiatric diagnosis was 1.44 when comparing COVID-19 to influenza patients, and 1.78 for any first diagnosis. These elevated risks indicate that COVID-19's impact on the brain may be more severe than that of the other respiratory illnesses, underscoring the importance of continued research into this relationship. The last part is for future research directions. Given that the potential long-term implications, what should future research focus on? Here are some key areas. First one, for the longitudinal cohort studies. Multi-year studies that track COVID-19 survivors over time could reveal whether COVID-19 truly increased the risk of dementia and help determine if these cognitive issues are temporary or progressive. Second, neuroimage studies. Use MRI and PET scans to monitor structural changes in the brain of COVID-19 survivors, especially in regions involved in memory and cognition, would allow us to identify early signs of neurodegeneration. Third, animal and in vitro models. Developing models that replicate COVID-19's impact on the human brain would provide insights into specific cellular response, studying neuroinflammation, BBB integrity, and neural health in controlled environments could reveal more about the virus effects. Last one, the genetic and immune profiling. Research into genetic and immune markers that may predict susceptibility to cognitive decline post-COVID-19 could lead to target interventions, helping protect the vulnerable populations. In conclusion, while we're seeing initial signs that COVID-19 might elevate dementia risk, there is still much to learn. Current studies suggest strong associations, but long-term data and causal evidence are needed. This line of research is crucial not only for the public health planning, but also for developing targeted treatments and preventive strategies to support COVID-19 survivors at risk of cognitive decline. Thank you for listening.